In today's video, we are going to solve the AC circuit using the superposition theorem. We are given this type of circuit, and using superposition, we are going to solve it by activating one source at a time while the other sources are turned off. First, we identify the independent sources connected in the circuits, which are 4 angle of 0 amperes, 12 angle of 0 volts, and 6 angle of 45 amperes. Next, Next are the impedances connected in the branches of the network, which are 6 angle of 60, 4 angle of 30, and 2 angle of 60. Now, we are going to solve the contribution of 4 angle of 0 amperes. First, we short the 12 angle of 0 volts and open the 6 angle of 45 amperes. This leaves the 4 angle of 0 amperes current source driving the remaining circuit branches and the load impedance. Using the current divider rule, we determine the current flowing through the 2 angle of 60 load impedance branch. Applying CDR gives us the current 1.977 angle of 5.024 amperes. Next, we use the Ohm's law to determine the voltage across the load impedance. Since the required value is in volts, so we multiply the branch current by the load impedance, which is 1.977 angle of 5.024 multiplied by 2 angle of 60. This gives us the voltage contribution of V1, 3.94 angle of 65.024 volts. Next, we solve for the value of 12 angle of 0 volts. First, we open both current sources, which are 4 angle of 0 amperes and 6 angle of 45 amperes, leaving only the 12 angle of 0 volts source supplying the circuit. Since the active source is a voltage source feeding the impedance network, we apply the voltage divider rule or VDR to determine the voltage across the 2 angle of 60 load impedance. Using VDR, we obtain the contribution 2.062 angle of 9.896. Next, we solve for 6 angle of 45 amperes. Again, we apply the superposition procedure by shorting the 12 angle of 0 volts and opening the 4 angle of 0 amperes, leaving only the 6 angle of 45 amperes current source driving the circuit. Using the current divider rule again, we determine the current flowing through the 2 angle of 60 branch, which gives us the current of 4.982 angle of 42.964 amperes. Next, we use Ohm's law to convert the branch current into the corresponding voltage across the load impedance, which gives us 4.982 angle of 42.964 multiplied by 2 angle of 60. This gives us the voltage contribution 9.964 angle of 102.964 volts. Finally, the total voltage across the 2 angle 60 load impedance is obtained by adding the phasor voltages produced by each independent source according to the superposition theorem. So we combine the voltage contribution 3.94 angle of 65.024 minus 2.062 angle of 9.896 minus 9.964 angle of 102.964. The negative signs appear because the current direction through the load branch goes downward relative to the reference polarity after the shorting and opening of other circuits, which reverses the polarity of those contributions. After performing the phasor addition, the final voltage across the load impedance becomes 6.766 angle of negative 73.957 volts.